Hello everyone, Ismail is here. How are you today? Today we're going to start a new lesson, which with the new modular 3.1, understanding rational exponents and radicals. Okay, so you can find all my lesson on my website. Now, you have here one up question. Try to solve it. If you have any question on this one, just text me. Okay, now let's go start with the some basic rules. Okay, that we need to know. Like this one, as you can see here, we have the first rule, the multiplication rule. So as you can see here, when we have a variables, these points mean multiplied. So when we have a variables multiplied with another variable, so we have same base with different power, we just add the power. So just an example. So let's say if we have x to the power of 5 times x, okay, x to the power of 3. So what we need to do, we just add the power, which is x5 plus 3, which is x to the power of 8. Okay. Now, when we have the second rule, power to a power. So as you can see here, when we have the base, and this base has a power, and all of this has another power. So as you can see, two powers together, we multiply the power. So as you can see another. So let's say we have 5 to the power, x to the power of 2, and this one to the power of 3. So we can write this one as x 2 times 3, which is equal x to the power of 6. Okay, another one, power of a product. So as you can see here, we have AB. So what you need to do with the AB, so distribute the power. So as you can see, distribute the N will be the power of B, and N also will be the power of A. So as you can see here, let's write an example. So let's say we have 5x, okay, and as you can see, let's say we have a power of a 3. So this 3 now will distribute it, okay, on the x, which is it will be the power of the x, and for the 5, which is it will be the power of the 5. So it will be now, which is equal 5 to the power of 3 times x to the power of 3. So always redistribute the power. Zero exponent. Zero exponent means when you have a variables to the power of 0, so always it's equal 1. Not only variables, all the numbers like this one. So let's say we have x to the power of 0 is equal 1. So let's say we have y to the power of 0 is equal 1. So let's say 3 to the power of 0 equal 1. Let's say 17 to the power of 0 equal 1. Another, let's say we have 6,000 to the power of 0. It's always equal. So any number, any variables to the power of 0 is equal 1. Now, the division, it's the, let's say, similar to multiplication, except in the multiplication, we add them, but here in the division, we minus them. So as you can see here, we have, let's say we have x to the power of 5 and x to the power of 2. Okay, so how we can write them? We just minus the power. So 5 minus 2, so x to the power of 3. Okay, then the last one here, the power of quotient. The power of quotient, it's similar to the power of the product. Okay, which is when you have a power, you distribute the power for both of them. Same thing, you have a power here, which is n, you distribute the power for the x and just distribute the power for the n. So as you can see here, just an example. So let's say we have 5 over 6, all of that to the power of 3. So you can write this one as 5. Just you distribute the 3 now for the 5 and for the 6. So 5 to the power of 3, 6 to the power of 3. Okay, so this is how you can do this one. You can still simplify this, which is 5 times 5 times 5. Do the same thing, 6 times 6 times 6. You get the answer, divide the answer, divide them, you get the final answer. Okay, clear? Now I hope these rules are clear to you. Actually, these rules, I just give them in this lesson just as a warming up things to just uh, turn on your brain. I need your brain work with some rules like this. Okay, now let's go to my lesson, which is talking about understanding the integer. So let's start with the power of a 3. So 3 means 3 times 3 times 3, which is equal 27. Same thing here, 3 times 3, okay, which is equal 9. And 3 to the power of 1, which is 3. So as you can see here, the power represents the numbers. As you can see in each example, the power is reduced by 1. So now dividing a power of a 3 by a 3 is equivalent to what? To reduce, okay? To reduce the exponent by 1. So that's how we did, which is reducing the exponent by 1. Now we have a rule here that I told you the non-zero number raised the power of 0 is always equal 1. So any number to the power of 0 is equal what? 1. To the power of 0, 1. Any number to the power of 0, also the fraction. Anything I told you it's equal 1, x to the power of 0, which is equal 1. Now, let's exploring the rational exponent or the rational, which is the radical. Now, read here. So a radical expression is an expression that's written using the radical sign. So the radical, we can call it as a rational, or we can say this one is a radical. Now, I know we can say this is square root of something, okay? But now, also the square root, we call this one as a radical thing. Okay, so now this one means, okay, the radical. Okay, don't forget. Now, with the two numbers. So as you can see here, first, number n, okay, number a, which is represent the base under the square root, okay, and n, what we call n here? We call n here index. Okay, so now when I ask you what is, like, give you an example, what is the index of this question? So the index is equal to 3. What is the index for this question here? So the index is 4. So the index always the small number, or let's say the degree of the root. Okay, degree of the root. So if we read here, the index shown here as n is a positive integer which is set of power. Then we have here the radical. Okay, now let's change the base word. Okay, and we will not write or say this is the base. We will call this one as a radical. Okay, so radical, this now a means is the radical. So now the radical, okay, so square root, okay, or let's say the root, which is a radical, and the index is n, shown as a here, can be any number n. Is odd, but it must be non-negative when n is even. Okay, now forget about this. Okay, don't make things complicated to you. Just now, let's focus on these two rules here. Okay, so now let's focus on these two rules here. So now the first rule, as you can see here, when we have a to the power of 1, okay, or we can write it as a only without 1, because all we don't write 1. So n square, sorry, root of index n a is equal always 1 over n. Okay, so this is how we can write it. And this one is always, as you can see, b m over n can be written as this one here. Okay, or sometimes you can take the m outside the bracket. So this one and this one are same. There is no difference between them. Both of them are same. But sometimes you will see some question we write them like this, and some question we write them like this. Both of them are correct. When we use each one, we use them depend on the question, which is which one is it easier to me? Is it easier to use this way, or is it easier to use this way? If this one is easier, so use this one. Don't use the hard one. If this one is easier to simplify, use this one. Okay. Then we have here the definition of nth root. The definition of nth root when you have a power, okay, is the same of the index. Always the answer is equal a. Okay, so always when we have a power of a, which is, let's say, example here. So let's say we have this one 3 and a to the power of a 3. So always when we have index equal the power, same here, always the answer is a. This cancel this one here, so the answer is equal a. Okay, I hope this understandable. Now, let's take these examples here. I know it's a lot of examples, so you can look to the first example of each, then you can skip if you need. So now, let's follow this rule to write my question. So the first one here, it will be 2, because this one is 1 here, so it will be 1 over 6. This one here, it will be also 1 here, so 2 over 1 over 3. Same thing here, 10, 1 over 6. Okay, for this one here, down, so it will be square root of 2, 7. Always the index should be in the denominator. If you look here, always the index will be in the denominator. Okay, so that's what you see here. Okay, we don't need to simplify. Just write the question as a radical. Okay, this one here. So we do the same thing. Now we need to follow this rule here. So look to this rule. Okay, m will be in the numerator, index always will be in the denominator. So it will be 5. So this one is m, this one is n, and we know m over n, so 4 over 3. Same thing here, 15, 7 over 2. Same thing, 23, 5 over 4. Okay, same thing here. Do the same thing. As you can see, this is m, okay, this is n. So it will be 27 m, sorry, not m, 2, okay, over 3. Okay, same thing here, 15, 4 over 5. Okay, the last one, 8, which is equal 5 over 7. Okay, so those are my question. Okay, how about this one here? So do the same. So as you can see, okay, let me write it in green. Okay, so we have this one, and we need to convert this one. So now, as you can see here, this one is my index. Okay, this one is my index, and this number 4 is the power. Okay, so you have to wait. You can write it like this: 3, 4 to the power of 4, or you can write it. Let me write it here, or you can write it root cube root of 4 to the power of 4. This one and this one are same, no different. Okay, let's do this one here. So it will be index 2, 6 to the power of a 3, or you can write it like this, 2, 6 to the power of a 3. Same, both of them are correct. Same thing here, a is equal 6, sorry, can you erase this? Okay, it will be 5 over 6. So I hope this one is understandable. Now, let's go to the next one. Let's complete the pattern to understand the index, okay, or the power of negative. So now let's understand this one here. So let's start with the first one. So as you can see here, when we have a number with a power and we divide this number with the same, so we just, if you remember, we just reduce the power. So like this one. So if let's say if we have 4 to the power, let's say 4, or let's say maybe it's 4 to the power of 3, divide by 4, we reduce the answer, we reduce the power only. Another example. So 4 to the power of 6 over 4. So we just reduce the power, which is 4 to the power of 5. Okay. Now, so as you can see here, 3 to the power of 3 divide by 3, it's 3 over 2. 3 to the power of 2. 3 to the power of 2 divide by 3, 3 to the power of 1. 3 to divide to 3, which is 3 to the power of 0. 3 to the power of 0 divided 3, 3, negative 1. Still negative 2. Okay? Now we do the same thing. If we divide 27 by 3, it's equal 9. Okay? 9 divided by 3 equals 3. 3 divided by 3 is equal 1. 1 divided 3, 1 over 3. 1 over 3 divided 3, 1 over 3 to the power of 2. Or we can say 1 over 9. Okay, so now look to the pattern here. What's happening here? So if you look here, 3 to the power of 0, always it's equal what? 3 to the power of 0 is equal 1. Same thing here. When we have a 3 to the power of negative 1, okay, we can write it as 1 over 3. When we have here 3 to the power of negative 2, we can write this one as 1 over 3 to the power of 2 and then simplify. Okay, so this example or this explanation just explaining this rule here. So as you can see here, the negative rule, okay, of this one or this one here. So as you can see, all of these three represent the same concept. So when we have a number with a negative exponent, so we can write this one as we remove the negative by writing 1 over the exponent. So if I need now to write this one, so I can write it as 1 over 3 to the power of 1. And if we have to anything, any number to the power of 1 means it's same thing. So we just cancel it. We don't need it. 3 to the power of 1. Or we can write it as a 3. Okay, same thing here. We can write it as 1 over 3 to the power of a 3. So 1 over 3 to the power of 3 means 1 over 3 times a 3 times a 3. Okay, we get the answer. Same thing here, 1 over 3 to the power of 2. Or we can write it as if 1 times a 3 times a 3, which is 1 over 9, right? So this is how we can simplify this. Now, let's take some examples here. So now let's follow the rule. So this is the first rule that we're going to use here. So as you can see here, this is the n, okay? And this is my base or the radicand. So I put it here. So I put 10, I remove the minus over 1. Same thing here. Okay, you can simplify this. Let me simplify it to get the final answer for each question. Okay, so the first one here, it's 1 over 10 to the power of 2, which is 1 over 100, right? Because 1 times 2, 10 times 10, because this one's 10 times 10, which is equal 100. Okay, this one here, it's 1 over 56 to the power of 1. And I told you to the power of 1 means same thing, no change. This one here, 1 to the power 2 over 4. So that's mean 1, 2 times 2 times 2 times 2. So 2 4 times. 2 4 times means 16. Now this one, 1 over 6 to the power of 2, 6 times 6, which is equal 36. So now this is my first question. Okay, now let's follow this one here. So 1 over 3 to the power of negative 2. Okay, now we need to follow, okay, now we need to follow this rule here. Okay, follow this rule here. So to follow this one here, so we flip and change the sign. So it will be 3 over 1 to the power of what? To the power of 2, right? Then we distribute the, if you remember, we distribute the power. Let me erase this one, change color. Okay. If you remember the rule that we can distribute the power for both number here, so it will be 3 to the power of 2 and 1 to the power of 2. Okay, right? So now 3 to the power of 2 means, okay, 3 times 3, which is equal 9. 1 to the power of 2, which is 1 times 1, which is equal 1. So 9 over 1. 9 over 1 means what? Means 9. Okay, let's do this one here. So now we flip and remove the negative. So 1 to the power of 4, 4 over 1, which is to the power of 5. So as you can see here, it will be 4 over 1 to the power of 5 to the power of 5. Okay, so now 4 to the power of 5, which is means 4 times 4 times 4 times 4 times 4. Okay, let me change the color to you. Okay, so 4 times 4 times 4 times 4 times 4. So 4 times, which is equal 1024. And 1 times 1 times 1 always always is equal 1. Okay. So 1024 over 1, which is equal 1024. Okay. Let's do the second one here. The same thing. Multiply, then flip. Flip, then change the sign. 13 over 4, which is, we just flip. Okay, so we just flip and we remove the negative. So it will be now 13 to the power of 4 and 12 to the power of 4. So you multiply, okay, 13, sorry. So you can just get the answer by using calculator. This one here, okay, we flip 6 over 5, okay, to the power of n. You can distribute the n or you can keep it like this, still same answer. Okay, how about this one here? This one here, 8 to the power negative 1 over 3. Okay, so here you can go back to this form here. Okay, so now let's do this form here. Okay, by applying 8 to the power 1 over 3, which is what? Same thing here. Okay, so we do 25 to the power of 1 over 2 over 1. Do the same thing here. 1 over 1, 2 over 3. Okay, same thing here. 1 over, which is the power of 35 over 1. Same thing. Okay, here, okay, you can flip and change. So it will be 4 over 1 and 3 over 2. So you can write it as 4 to the power 3 over 2. Clear? Yes, I hope this one is clear. Okay,